start with now properly the subject data structures. What we had considered in the last lecture, that was just the concept of pointers, okay, which we will be requiring henceforth every now and then. And prior to that we had even discussed the sparse matrix, which is again a type of data structure, but we have not dealt it in that particular manner. We were mainly concentrating on optimizing the memory required for the storage of the matrix, maintaining the positional relation among the particular items or the values. And then we had even discussed about the matrix operations which are mainly there. If you are looking for some operations like finding the inverse and all, that is going to be very complicated. Standard operations like addition, multiplication and transpose, those are the ones which we have discussed. And you know that the inverse etc. can be found out by some other techniques also. Like you have IA or IAI type of thing where the row operations are performed. But then those typical ways of finding the inverse in case of a matrix which has got number of zeros, probably the actual storage will be much more effective, the matrix type of storage, than the sparse representation. Because in sparse you are required to check, when you are subtracting two elements in the same matrix, you are required to check whether they belong to the same column when you are performing the row subtraction as such. And then that factor has to be found out and whatnot. So there will be unnecessary checks which will be coming into picture, and the cost of the operation will go on increasing. It will become more and more complex because you are using a different representation for storage. It will be at that time better that you shift the matrix to the standard form, that is from sparse. Like we have written a function where a matrix is to be converted to the sparse notation. Now you will have to write a exactly reverse type of function from sparse to the standard matrix. Once you write that function, most of the job will be through. So you take it temporarily to the standard form, perform the operation and then take it back. We have used actually that policy in the matrix multiplication, because we have said that, but over there it was not the job of converting the sparse form to the standard matrix, but we were multiplying the two matrices and the result was directly going to the standard matrix form. That is how we have written it. But one additional function you will have to definitely write to convert sparse form to the standard matrix. Then the job will be done. Of course, our teachers are not giving us the assignments which are really based on the sparse application as such. So other than addition, multiplication, simple transpose, fast transpose, you can restrict yourself only to these type of assignments, and even in the exam you will have the same thing. At the most the change could be you can use one-dimensional array, one type, or the second type it could be using the pointers you will have to do it, like the one which we have seen last time. And the third case which we will come across afterwards, after learning the linked list, that you implement sparse representation using linked list. That's it. But the basic concept and basic checks are not going to change any moment. Only thing is whether you consider it as array or whether you consider it as a pointer and use the dot operator or arrow operator, and you will be through. So that will not be a big issue. Like you have declared the sparse as a particular array of 50 elements, instead of that you can dynamically allocate it. But other than that there will not be any difference. In a few colleges, instead of using the structure, they have even suggested a two-dimensional array. When we use two-dimensional array, in that case there will be three columns. First column representing, column 0 representing row number, column 1 representing the column number of the original, and column number 2 will represent the value. The only drawback in that representation is you cannot have the value as float, because then row number, column numbers are integer. Obviously in a two-dimensional representation the third column will also contain the integer value. Okay, so if the application, if they specifically say that use two-dimensional array, then wherever we were saying that sp1 square bracket say k1 dot row, instead of that it will be sp1 square bracket k1 square bracket 0.